In this lecture, we'll learn how to use the conservation of energy law to calculate the transmitted intensity and the reflected intensity. My name is Joe, and I help people understand ultrasound physics and pass the SPI exam. So first, what is the conservation of energy law? Energy is neither destroyed or created from nothing. It can only be transformed to another form. For example, transformation of the ultrasound energy to heat. That means that the total energy of an isolated system is remaining constant. So that will take us to transmission and reflection coefficient. So when we have sound beam, which is a strike, a boundary, some of this sound beam will transmit to another medium, and some of this sound beam will reflect back. So we will use the conservation of energy law to calculate the reflected intensity and the transmitted intensity. Because the total of energy is supposed to be the same in an isolated system, so the reflected intensity plus the transmitted intensity have to be always equal to the incident intensity. So this is the first equation. We have the incident intensity always equal to the transmitted intensity plus the reflected intensity. But this is only if there is no energy loss. For example, if there is no absorption, because when absorption happens, the sound energy will convert to heat. So we here suppose that there is no absorption. And from this equation, we can tell that the transmitted intensity equal to incident intensity minus the reflected intensity. And we can calculate here intensity reflected coefficient. The intensity reflected coefficient is the percentage of the reflected sound beam. So how much in percentage of this sound beam will reflect back. And we also can calculate the intensity of the transmitted coefficient. How much in percentage beam was transmitted and how much percentage will reflected. So in order to calculate the reflected coefficient, intensity reflected coefficient, it will be equal to the reflected intensity divided by incident intensity multiplied by 100. So the reflected intensity divided by incident intensity multiplied by 100. Now, how can we calculate the intensity transmitted coefficient, which is this one? So we need to multiply the transmitted intensity by the incident intensity and multiply by 100. So we'll get it on a percentage. The intensity reflected coefficient and the transmitted intensity coefficient, total of this always equal to 100. And this is due to the conservation of the energy law. It's equal to 100%. For example, if we have the intensity reflection coefficient, if we have it 40%, so for sure the transmitted coefficient have to be 60%, because 60% plus 40% equal to 100%, which is the total of the energy. The conservation of energy law will apply whether the incident is an oblique incident or a normal incident. We also will use the conservation of energy to understand the hemodynamic. In the next lecture, we'll talk about the difference between the oblique and the normal incident. Thank you for watching and see you in the next video.